Since the dawn of civilization, humanity has looked up at the night sky, wondering, are we alone in the universe? With billions of stars, many with their own planets, the possibility of extraterrestrial life seems tantalizing. But how do we estimate how many alien civilizations might exist out there? Enter the Drake equation, a tool that has captivated scientists and stargazers alike for over half a century. Developed by American astrophysicist Dr. Frank Drake in 1961, the Drake equation is a formula that attempts to estimate the number of technologically advanced civilizations in our galaxy, the Milky Way. But it's not just a single number, it's a series of factors multiplied together. An equals are times Fp times Ni times Fl times Phi times Fc times L asterisk. Let's break it down. The equation looks like this. An equals the number of civilizations with which humans could communicate. But this is only one part of a much larger formula that includes several key variables. Our asterisk is the rate of star formation in our galaxy. We know that new stars are constantly being born in nebulae, clusters of gas and dust, scattered throughout space. On average, about one new star forms every year in the Milky Way. But the real question is how many of those stars have planets that might support life? Fp is the fraction of those stars that have planets. Thanks to modern technology like the Kepler Space Telescope, we now know that planets are common throughout the galaxy. In fact, recent estimates suggest that nearly every star has at least one planet. This variable has grown over time as more exoplanets are discovered. Ni is the number of planets that could potentially support life around each star. We're talking about planets in the habitable zone, where conditions are just right for liquid water, one of the key ingredients for life as we know it. Scientists estimate that a significant fraction of stars with planets could host at least one habitable world. Fl is the fraction of those planets where life actually emerges. This is where things get tricky. We only have one example of life Earth. While it seems life arose on our planet relatively early in its history, we don't yet know how common that process is or whether life could arise on other planets under different conditions. Phi is the fraction of planets with intelligent life. Life could evolve in many forms, but intelligence, as we understand it, is rare. On Earth, it took billions of years for humans to evolve from simple life forms to beings capable of building cities, space probes, and technology. How likely is it that intelligent life evolves elsewhere in the galaxy? Fc is the fraction of civilizations that develop the ability to communicate across interstellar distances. Here, we're talking about technological advancements, radio signals, lasers, or other forms of communication that could reach across vast distances of space. On Earth, we've been broadcasting for over a century, but how many other civilizations in the galaxy have done the same? And finally, L is the length of time a civilization can communicate. This variable is perhaps the most uncertain. Civilizations might thrive for millions of years, or they might destroy themselves in a few centuries, preventing contact with other life forms. Environmental changes, technological advances, and even self-destruction through warfare or resource depletion could drastically shorten a civilization's window for communication. While the Drake equation sounds like a straightforward way to estimate alien civilizations, there are significant challenges. Many of the variables are based on our current understanding of science, but many of them are still largely unknown. For example, we don't know how often life actually develops on habitable planets, or how likely intelligent life is to emerge. The fraction of civilizations that develop communication technology and the lifespan of these civilizations are still pure speculation. So, while the Drake equation gives us an estimate, it's a highly speculative one, filled with uncertainties. Despite its uncertainties, the Drake equation has sparked a revolution in the search for extraterrestrial life. It serves as a guide for scientists to narrow down where we should focus our efforts. As we continue to explore distant planets and listen for signs of alien signals, the equation helps frame the questions we need to ask. Even though we don't yet know the number of alien civilizations in our galaxy, the fact that we can estimate this number, however roughly, opens up exciting possibilities. The search for life beyond Earth continues to evolve, and the answer may be just a few light years away. As we continue to refine the variables in the Drake equation, new discoveries are being made every day. The discovery of thousands of exoplanets, some in the habitable zone, and advancements in detecting alien signals could soon give us new clues. Perhaps one day, the Drake equation won't just be a theoretical tool, but the key to finding a new civilization in the stars. Until then, the mystery remains. How many alien civilizations are out there? While we may not know the answer yet, the search is far from over. Thank you for joining us on this cosmic journey. Don't forget to like, share, and subscribe for more exploration into the unknown.